Hello, Jennings Geniuses. Today we're going to do a little review of word problems with hidden information and a little review of lines and line segments, rays and angles with geometry. Then we're going to talk about 3D shapes. I want to start by going over some of the word problems you had for homework. I saw more than a few incorrect answers on some of them, so I want to make sure that we clear up any misunderstandings. In this word problem, Aiden, Tarun, and Olivia went to the Slushy King stand at the water park. Aiden got the biggest slushy, and his slushy had a 1 foot 3 inch straw. Tarun bought a slushy with a 1 foot straw, and Olivia bought a slushy with a 10 inch straw. Now we know just what a math zombie would do. They would say, she said how many inches in all, I'm going to add, but this is not going to lead to the correct amount. If I add that, 1 and 3, 4, 5, 15 inches in all. Is that reasonable? No. So let's think about what number was hidden. And what was hidden was the 12, because there are 12 inches inside of this foot and 12 inches inside of this foot. So you had to have some prior knowledge. You had to know that a foot is 12 inches. Now I could add 12 plus 3 plus 12 plus 10, but I already know 12 plus 12 by heart. So that's 24 inches plus 10, that's 34 inches, plus 3 more, that's 37 inches. And I showed my work. All right, I hope you got that one right. Let's look at the next one. The next one was about renting canoes at the park, which you can do now because the parks are open. Yahoo! Tobias rented a 10-foot canoe. Charlotte rented a canoe that was 3 yards long, and Ashley rented a canoe that was 2 yards and 2 feet long. Well, we can't, again, we're supposed to find out who has the longest. So this person's is 10, this person's is 3, and this is 2 plus 2. This is what a math zombie would say. But we know the numbers represent different things. This 10 is an adjective describing feet. This 3 is an adjective describing yards. And in this one, the 2 describes yards and this 2 describes feet. So we need to get them all in the same unit. So let's turn those yards into feet. How many feet are in a yard? There are 3 feet in a yard. Think of the yardstick. So now we know that if this is 2 yards, that's going to be 2 times 3. What is 2 times 3? 6 feet. This one is 3 yards long. This one's going to be 3 times 3. What is 3 times 3? You may already know the fact, or you could just say 3, 6, 9. That's 9 feet long. And Tobias's is, oh wait, we didn't add this last thing. She had 6 feet plus 2. So hers is 8 feet total. Hers is 9 feet total. And Tobias's canoe is 10 feet total. So the answer was Tobias had the longest canoe. And last but not least, this is the last one I want to go over. The last one I saw problems with. It was the math facts. Yolanda memorized a multiplication fact 1 per day for 10 weeks. Mackenzie learned 1 fact per day for 2 months. Now, we have to get these into the same unit. This 10 is an adjective describing weeks. This 2 is an adjective describing months. So to solve this, you would need to know how many weeks are in a month. And I know you know this from all the time we spent on calendar. There are 4 weeks in 1 month, and Mackenzie studied facts for 2 months. So she studied facts for a total of 8 months. So who learned more facts? Not 8 months, I'm sorry. 8 weeks. So who learned more facts, Mackenzie or Yolanda? And the answer was Yolanda, because 10 weeks is 2 weeks longer than 2 months or 8 weeks. All right, let's do a quick review of lines and line segments and angles and all of that. All right, so I'm going to just show it to you and I'll see if you can say it out loud. What is it? Yes, that is a ray. It has an endpoint on one end. It goes on infinitely in the other direction. That's ray AF. You always have to name a ray with the endpoint first. So if I wanted to write the name of this with geometry notation, I would write that. That says ray AF. Let's see if you remember this. What's this? It has an endpoint. It has an endpoint. It's straight. It's a 2D plane, plane, flat shape. Right. It's a line segment. It's a piece of a line, but it ends at endpoints. And if you wanted to write the name of this, you could call it line segment CD. You could also give it another name. You could call it line segment DC. All right. What's this? That's a reptile. What's this? Let's look at that one. It has points on it. It actually has an infinite number of points. And it goes on forever. It goes on infinitely in both directions. That is a line. And sometimes you might see lines that look like this, and we would call those parallel lines. Mine's not perfect, because if they both kept going on forever, they would not intersect. And you could write the name of this as line AB. You have to put the little arrows. Or you could call it line BA. All right. And here we have some angles. Now, the most common angle, we look around the room where you are, at the furniture, at the corners of the room, at the shape of the door. In construction and in a lot of things, we have a lot of things with 90-degree angles. And another way you can call that is a square corner. Or you could also call it a right angle. So think about your house. If they didn't build it 90 degrees, the walls and the floor, that would be the wrong angle. Luckily, they did it right. They made it a right angle. And there are just different categories of angles. Angles are rays. They meet at an endpoint. This endpoint is called a vertex. And they're named or categorized by the number of degrees in them. So this is smaller than 90 degrees. The way I remember it is it's just a cute little angle, and that's called acute. When it's wider, fatter than 90 degrees, it's called an obtuse angle. And this one's weird. If it's looks like a straight line, but it has that vertex, that's actually a straight angle. And inside of it, it has these 90 degrees, whoop, plus 90 more here, whoop. So that angle is 180 degrees. All right, now let's move on. I'm sorry this is crooked. I'm just in a weird situation here. Today I want to talk about 3D shapes. They have 3 dimensions instead of 2. And the first one I'm going to start with is a cube. It has height, width, and length. Height is what makes it 3-dimensional. When I had all those other shapes, they were plain shapes. Bam! If I draw a square, that has 2 dimensions. It has length and width, and it's flat. When you add that 3rd dimension of height, that's where the 3D comes from. If you go to a movie that's in 3D, it's going to look like things are taking up space instead of flat. 3 dimensions. Now, when we talk about 3-dimensional shapes, they have certain attributes. If they have flat parts on them like this, these are not sides. A square has sides. A square has 1, 2, 3, 4 sides. But these aren't sides. These are faces. So how many flat faces are on the cube? Let's see. 1, 2. Don't forget the one at the bottom. 3, 4, 5, 6 flat faces on a cube. It also has places where flat faces meet. Wherever flat faces meet, that's called an edge. So if you want to count the edges on a cube, you've got to count all the ones around the top, all the places where the flat faces meet around the side, and all the places where they meet at the bottom. So let's count the edges. And on this shape, the edges are either going to be dotted because I folded this. Help me count the edges. 1, 2, 3, 4. Go around the side. 5, 6, 7, 8. Go around the bottom. 9, 10, 11, 12 edges. Now, where these faces meet, right here, which what we might refer to as a corner, where these edges are all coming together, right there, the edges are all coming together, that is a vertex. Just like an angle had a vertex, that is a vertex. So we can count how many vertices this has, or you might refer to them as corners, but they're really vertices. 1, 2, 3, 4, 5, 6, 7, 8. Now the cube is a three-dimensional shape we're all really familiar with. Let's go on to another familiar 3D shape. And you see this a lot, like a box of tissues, or things you buy at the store come in boxes this shape. I just bought some eye drops in a box like this. This and this, these are both in the same family. This is called a rectangular prism. And here's that word, because you're going to hear it a lot. A rectangular prism. And think about how it would be similar when I count the faces. What do you notice about the faces on those two? The faces are these flat surfaces. Right. This shape looks like that one, just stretched out longer, so it's going to have the same number of faces. It's going to have 6. It's going to have the same number of edges where flat faces meet. It's going to have 12. And it's going to have the same number of vertices. It's going to have 8. Cube, rectangular prism. Now let's continue to think about prisms. Here's a prism, but this one is a triangular prism. Prisms are named for their end shape. So here's my triangular prism. And I look at it and I want to count my faces, flat places, flat surfaces. I count 1, 2, 3. I count the one at the bottom. 4, 5. So the triangular prism is different. It has 5 faces. How many edges where sides meet? 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many corners or vertices where edges meet? 1, 2, 3, 4, 5, 6. Now all 3 of these are prisms. But this prism has a special name. We call it a cube. This one's the rectangular prism, the triangular prism. Now let's look at some other shapes. These shapes are called pyramids. And I know I have a lot of history buffs in my class who've read about the pyramids of Egypt. Well, the pyramids of Egypt look like this. I think we saw a picture of them at the Charleston Museum. So I'm noticing I see shapes on the faces. These shapes are triangles. 1, 2, 3, 4 triangular faces. Now, if I turn it over though, and this little tippy vertex at the top has a special name too. It's called the apex. It's where all these vertices meet in the point at the top of the pyramid. But if I flip this pyramid over, the base of it is what shape? Right. It's a square pyramid. The pyramid is named for its base. So this would be called a square pyramid, even though it's got triangles on the side. All pyramids have triangles on the side. The bases are what will change. So let's count the faces. 1, 2, 3, 4. Don't forget the bottom 5. Let's count the vertices. We can start with the apex. 1, 2, 3, 4, 5. And we can count the edges where two flat surfaces meet. 1, 2, 3, 4, 5, 6, 7, and 8. Now remember, pyramids are named for their base. And so here's a pyramid, and it has what shape for a base? It's the same, no matter how I turn it. It's the same. This is a triangular pyramid with the triangle at the bottom. And last but not least, I wanted to show you this one. This one is kind of special. This is a cylinder. It rolls. Unlike all the other shapes, it rolls. And do you remember what we call these flat surfaces? They're faces. It has a face here. I flip it over. It has a face here. But does it have edges? Because edges are where two flat faces meet. Here's a flat face. Here's a flat face. Are they ever going to meet? No, they are not. So the cylinder is very weird. It has two faces. Does it have any edges where flat surfaces meet? No, it has 0. Does it have any vertices where two straight edges come together? No, it can't have vertices because it has no edges. And how about recalling the name of it? What do you call this? It's a cylinder. Now, y'all, I attached these foldable shapes to the lesson. I encourage you to print out, not all of them, but print out 1 or 2 and fold them. Do not start with the cylinder. The cylinder will give you anger at 3D shapes. It is a super challenge one. Do the other ones first. There's also a hexagonal prism. That means it's going to be this with a hexagon on the end. I would save that for last as well. But one piece of advice, before you begin folding, make sure you have creased every little dotted line, or you will go crazy. So in other words, if this were my shape, and I'm just using a scrap because I'm printed double-sided, if I were going to fold this, I would make sure that before I even started taping that I fold every single dotted line, every single one, and that will help it to take the right shape, and it will allow your other hand to be free to put the tape on. So anyway, good luck with those, and there's a short video to watch. See you next time.